Hello students, in this session we are going to solve a Booth's algorithm numerical that is -6 into 2. We are taking here multiplicand as -6 in M register and multiplier as a 2 in Q register, right? So whenever I am saying here -6, so 6 equivalent binary value is 0, 1, 1, 0, and 2's complement of 6, that is -6, is 1, 0, 1, 0. So while solving the numerical, we are going to consider this 2's complement of 6, right? And in the Q, in the multiplier, 2 binary equivalent is 0, 0, 1, 0. So initialize this capital A register to 4 times 0, then Q as multiplier, that is 2, that is 0, 0, 1, 0. Q minus 1 initialized to 0, and your multiplicand will remain as it is, since we are going to use only for the addition or subtraction. So this M column will be same in every Booth's algorithm numerical. So here we are going to take 2's complement of 6. That means -6. 1, 0, 1, 0. Okay. So -6 यानी 6 का मैंने 2's complement लिया है यहाँ पे, right? Now let's solve. This is your initial value. These are your initial values. Now observe this Q0 bit and Q minus 1 bit, right? So both these are 0. So according to the flow chart, when Q0 is 0 and Q minus 1 is 0, we will first shift right the content of A, Q and Q minus 1. So let's do this shift right operation. Shift right the contents of A, Q and Q minus 1. Why? Because your Q0 is 0 as well as Q minus 1 is equal to 0. So that's why we are taking shift right operation, right? So 0 space 0 space 0. Now this 0 will get shifted in Q column. So 0, 0, 0 and 1. This 0 will get shifted into Q minus 1 column. So now it will become 0 and M will remain as it is. Okay. Now after that, again observe, see, we will be scanning this Q0 bit and Q minus 1 bit always. Who does this? The control unit will be scanning all the bits of Q, right? So here the Q0 bit is 1 and Q minus 1 bit is 0. So let's check what is there in flowchart. When it is 1, 0, then we will be subtracting the 2's complement of M from A. That means we will be adding the 2's complement of M with A and then we will be storing the result in A. So let's do this operation once again. So here the current value of A, here A equal to A minus M, that is, I will write it into bracket, A equal to A plus 2's complement of M. Why we are doing this? Because the Q0 bit is equal to 1 and Q minus 1 bit is equal to 0. So that's why we decided to do the subtraction with 2's complement, that is addition with the 2's complement. Okay. Okay. Now, so what is the current content of A here? A is equal to 0, 0, 0, 0, right? Now I want to take the 2's complement of M. What is M here? 1, 0, 1, 0. That means I should take the exact value of 6. 2's complement of 1, 0, 1, 0 is 0, 1, 1, 0. So this is 2's complement of M. So what is the current value of M? It is 1010. So 2's complement of M will be 0110. So here I will do the addition, right? And I will get the answer as 0 space 1 space 1 0. So this is the actual value which I am going to store it into register A. This value store it at this one, 0 space 1 1 0, and Q will remain as it is, Q minus 1 will remain as it is, M will remain as it is, right? So in the flow chart, see, after every arithmetic subtraction or addition, there is a arithmetic shift right operation. So we are going to perform this after every step, right? So after doing this subtraction, we will shift right the content of A, Q and Q minus 1. So now this is A n minus 1 position bit. This will come to A n minus 2, as well as this will remain as it is in the A n minus 1 position to indicate the sign of the number. So I'll write here 0, right? 0 space 0 1. So this bit has been shifted right. Every bit we are going to shift right. Okay. So this bit will come here. Okay. Now this one will come at Q minus 1. Okay. And will remain as it is. Now after this, so this is your first cycle. In first cycle we have done only the shift operation. So in the second cycle we have done the subtraction, that is 2's complement addition, and after that we have done the shift right operation. Okay. Yeah. Next, after second cycle, now observe again the Q0 bit and Q minus 1 bit. We'll observe this flow chart. So Q0 is 0 and Q minus 1 is 1. So we are going to add the content of A plus M and store the result in A. So what we will do here, we'll take A, M. So what are the current contents of A? It is 00, 1. So write it here 0, 0, 1, 1. Now, are we going to take any 2's complement or this? No. We are going to take the original M value, which is 1, 0, 1, 0. Okay. Now after addition, the result is stored in A. So therefore, here after addition, I will get 1, 1, 0, 1. So you are going to follow the truth table of add, right? Yeah. So this value of A, put it here. 1, 1, 0, 1. Right? Q will remain as it is. Q minus 1 will remain as it is. M will remain as it is. So what we have done here? We have done A equal to A plus M. Why? Because Q0 is equal to 0 as well as Q minus 1 is equal to 1. Right? So therefore we have done the addition. Okay? Now, after every addition or subtraction, shift right the content of A, Q and Q minus 1. So now what is present at A n minus 1 position? It is 1. Right? So we will write it at A n minus 1 position as well as A n minus 2 position. Okay? So this bit has been right shifted here as well as it has been restored. That means it has been placed at the same position to indicate the sign of that number. So right, now this one you are going to shift it here, 1 space 0 space 0. Okay, so this has been right shifted. Now next, this 0 will come here. Okay, and M will remain as it is. Okay, so this is your third cycle. Okay, now what we are going to do? Again we are going to scan the bits of Q0 and Q minus 1. Now if you'll observe it properly, the bit of Q0 is 0 and Q minus 1 is 0. So from the flow chart, if Q0 is 0 and Q minus 1 is 0, we simply do the shift right operation. That means we are going to shift right the content of A, Q and Q minus 1. So do the shift right operation. Okay, so 1, that means this one has come here. This 0 has come to Q n minus 1. This 0 will come in Q minus 1 column, right? Why we have done the shift right operation? Because Q0 is equal to 0 as well as Q minus 1 is equal to 0. Okay, so this is your fourth cycle. Now, if we will observe it properly, the product, the final product result is present in register A and Q. So the product by algorithm, by Booth's algorithm, is minus 12. Okay, so I will write here product Booth's algorithm is 4 times 1 0 1 0 0, which is equivalent to minus 12. Okay, so this is your final answer. So don't get confused, students. Everything has been solved properly. Whenever any negative numbers comes as a multiplicand or as a multiplier, you should take their 2's complement and solve the numerical. Right? So how you are going to cross check the numerical whether it is correct or not? So whatever the product you will be getting it in A and Q register, so you are going to check whether this number is positive or negative. Since minus 6 into 2, that means we will get minus 12. Then you are going to convert this binary value into decimal, then you will come to know that our result is correct. Right? So thank you for this. I hope you understood this numerical, and thanks a lot.